Thank you. Today I am going to discuss about combination of error. When a number of physical quantities are involved in final calculation, then errors associated with the measurement of all physical quantities will affect the result. The final result depends on number one, the error in the individual measurement, number two, the nature of mathematical operations done on them to arrive at the final result. For example, say equivalent resistance in series combination is R is equal to R1 plus R2. So the error on R1 and error on R2 affect the equivalent resistance or the density is equal to mass by volume. Here the error on mass and error on volume affect the measurement of density. This is the error in the individual measurement affect the final result. Now the mathematical operations. Here the mathematical operation is addition, or here the mathematical operation is division. So the calculation of error is not same as the calculation of error in that case. Here the individual physical quantities are in addition. Here the associated physical quantities are related with division. So the error calculations are not same because their mathematical operations are different. Here the addition and subtraction have the same type of calculation, and multiplication and division have the same type of error calculation. Now see how we measure the error. Now sum and difference. When the final result of an experiment, say it is Z, depends on another two physical quantities x and y in addition or in subtraction form, then we can express final result is equal to x plus y or x minus y. Here we let the individual error of x and individual error of y is del x and del y. Then the individual then the error in final result will be must be the absolute error is equal to absolute error in x plus absolute error in y. If the physical quantities are in subtraction form, then also this is valid. That means all time the individual's errors, individual absolute errors are added if the physical quantities is in form of addition or in form of subtraction. All time the individual's errors are added. Here when two physical quantities are added or subtracted, the limiting error in the final result is the sum of the limiting errors in the individual physical quantities involved. Now take one example. Say perimeter of the rectangle. It is equal to 2 into length plus breadth, we know them. So to get perimeter, must you have to measure length and breadth. If L, that means when we measure length, then we get the absolute error of L is del L, and absolute error of B, that means breadth, when you measure breadth, then it is B del B. Then the perimeter, that means when you calculate the perimeter, then the absolute error on perimeter will be del L plus del B. Here the 2 is the constant, so this 2 will not affect the error on the final result. Now the product and quotient. In the product and quotient, the rules are different than the sum and difference. Product and quotient. When the two physical quantities are in multiplied or divide form, the fractional error, here the fractional error, there was the absolute error. The fractional error in the final result is the sum of the fractional error in the quantities to be multiplied or to be divided. So take the final result Z is calculated by the multiplication of another two physical quantities x and y. Then the fractional error of the final result is equal to fractional error of the first physical quantities plus final fractional error of the second physical quantities. If there are another third one, then also it will be plus 3, must be it is in multiplication form. So for example, we know that momentum is equal to mass into velocity. So here the when to measure momentum, must you have to measure mass, and must you have to measure velocity. When you measure mass, then we get its fractional error is del m by m, and when you measure the velocity, then it is be del v by v. This is the fractional error of velocity. Then the fractional error of the resultant result, or that means fractional error of momentum will be del fractional error of mass plus fractional error of velocity. Now for division, if the final result is expressed in the form of division of x and y, then also the fractional error of the final result is equal to the fractional error of first physical quantities plus fractional error of second physical quantities. For example, say density equal to mass by volume. So the fractional error of density, that means in result it will be fractional error of mass plus fractional error of volume. Now if there are addition and multiplication and division, both are there, that means if z is expressed in the form of x by say yp, then what will be? Then the fractional error of z, that means of result, is equal to fractional error of x plus fractional error of y plus fractional error of p. That means all fractional error will be added. It is in multiplication form or it is in the division form. Now the last one, power of measured physical quantities. If the final result z is expressed in the form of x to the power m, x is the one physical quantities, m is the power, that is the numerical power, then the fractional error of final result is equal to m into fractional error of x. For example, we know that area equal to length square. So if you, when you find out the area, then must you have to find the length. When you find the length, then its error is say, fractional error is say del L by L. Then what will be the fractional error of area? It will be 2 into fractional error of length. Now the another example, if z is equal to x to the power m by y to the power n, m and n are the powers of a integer, then fractional error of z final result is equal to m into fractional error of x plus fractional error of y. Now take the last example, and it is a complicated example. Say we know that we measure hypotenuse square is equal to, we know that it is the base square plus perpendicular square. So we know that hypotenuse is equal to what is hypotenuse is equal to square root of b square plus p square. So if you measure this hypotenuse by measuring, or if you calculate a hypotenuse by measuring base and perpendicular, then what will be the error? Then the absolute error must be the addition, absolute error of h. What will be? Here the power is half, total power, so it will be half, then it is multiplied the 2 into, it is the b plus 2 into p. That means ultimately it will be del b plus del p. That means hypotenuse, the absolute error of hypotenuse will be absolute error of b plus absolute error of p. This is the calculation of error of the final result. This is the procedure, and you practice by the some examples, and we give some examples at the next video. Thank you.